This is Formal Lab 2, Playdoh Circuits by Grace Doyle, Dinara Giroux, and Rachel Powers. The problem at hand was to create a Playdoh resistor and determine its resistance. The punchline is, though, to create a successful circuit that follows all requirements. Our motivation is to explore and further understand the resistance capabilities of everyday household items. Our research question is, can Playdoh act as a viable resistor in a circuit while satisfying the mandatory specifications? And we found that Playdoh can successfully act as a resistor in a complicated circuit, and it can be manipulated in different ways to create outcomes of interest. Our circuit included 4 1.5-volt batteries, 10 alligator clips, a motor, an LED light, a Playdoh resistor, and then a 22 ohmic resistor. We manipulated the size and shape of the Playdoh to achieve a working circuit. We ended up with a small cube as our resistor shape, and most of the data was collected using a multimeter or a simple ruler. Then we used these values to calculate the resistance and eventually form a power box. Some requirements for a working circuit were that the motor will only run on at least 300 milliamps of current, and the light bulb needs at least 2 to 3 volts to light up, but no more than 20 milliamps or else it will burn out. Here's a photo of our circuit showing 3 loops, the Playdoh and ohmic resistors, and a lit light bulb and a spinning motor. A circuit is a closed path that allows electricity to flow from one point to another. There are 2 different types of circuits, series and parallel. In a circuit that's in series, there is only one path for the current to flow. In a circuit that's in parallel, there is more than one continuous path for the current to flow. Here's a model of the circuit, including a system schema. The yellow box is our Playdoh resistor, and the white box is an ohmic resistor. It is important to note that the ohmic resistor has a negligible effect on the circuit, as it is only there to satisfy what was an original mandatory aspect of our circuit. The arrow shows the direction of the current. Here's a model of the Playdoh resistor. We opted for a small cube resistor after changing the shape and size of the resistor many times to create a working circuit. The dimensions are shown as well as the resistivity formula. The resistivity was observed using a multimeter, so this formula was rearranged given the resistivity, length, and cross-sectional area to calculate the resistance of the Playdoh. Here's the power box showing that the motor received most of the current, while the other current was passed through the junction to the Playdoh resistor and light bulb. The separation of current shows that there are 2 viable loops in the circuit. The voltage drop in the second loop shows that the Playdoh resistor and the light bulb are in series with one another, but in parallel to the motor. The Playdoh resistor had a higher voltage drop than the light bulb. The main scientific principles referenced were the physics behind circuits, including Ohm's law, the construction of power boxes based on circuits, and the first law of resistivity. Here's the calculation of the resistance of the Playdoh resistor. The values on the bottom are important values that were previously measured or calculated, and these were used to calculate the final resistance of 11.37 ohms. It makes sense that Playdoh can act as a resistor. From what we know about resistors, Playdoh, and any material containing salt for that matter, is able to conduct charge because the salt inside allows for movement of positive and negative ions. The first law of resistivity, guided by the concepts of Ohm's law, allowed us to create a working circuit with a homemade Playdoh resistor and working parts. We know that the circuit was viable because it worked. For the same reason, we know that the light bulb received somewhere between 2 and 3 volts and did not surpass 20 milliamps, and the motor received at least 200 milliamps. Therefore, Playdoh can act as a resistor in a circuit. Playdoh contains salt, allowing it to be conductive as positive and negative ions are able to be transferred throughout. There is plenty of room for error in this experiment, but most of it stemmed from data collection and measuring resistivity using the multimeter, as well as measuring the dimensions of a resistor using only a simple ruler. We also changed the size and shape of the resistor multiple times in order to get a working circuit. When handling the Playdoh, we also added a lot of finger oils, which is non-conductive and may have had an effect on the circuit which we could not measure.